There is a ship in the North Sea with legs. When it arrives on location, it stops, lowers those legs through 40 meters of water to the seabed, and lifts its entire hull clear of the ocean. And then, from a platform that no longer moves with the waves, a crane the height of a 30-story building picks up a single wind turbine blade, 80 meters long, heavier than two fully loaded coaches, and holds it perfectly still while workers connect it to a machine spinning in the wind 120 meters above the sea. This is how offshore wind turbines are built, and the engineering required to do it is far more extraordinary than most people realize. Let's start at the bottom, because everything begins on the seabed. An offshore wind turbine needs to stand firm in a body of water that can generate waves over 15 meters high and currents strong enough to move cars. The foundation has to be capable of withstanding not just the static weight of a structure that can top 900 tons, but the constant dynamic loading of wind and waves, forces that will hammer the foundation billions of times over a 25-year design life. The most common solution for shallow and medium-depth water is the monopile, a single steel cylinder, typically 8 to 12 meters in diameter and up to 100 meters long, driven vertically into the seabed. These are among the largest steel tubes ever manufactured. A single monopile can weigh over 1,500 tons, more than 10 fully loaded jumbo jets. They arrive at the installation site by heavy lift vessel, are upended into vertical position by crane, and then hammered into the seabed using a hydraulic pile driving hammer. The noise generated during piling is intense enough to affect marine mammals, requiring noise mitigation measures across the entire installation zone. In deeper water, jackets are used instead, four-legged welded steel structures, similar to an oil platform jacket but optimized for wind loading. These spread the load across multiple piles and can reach depths of 60 meters or more. The emerging frontier is floating offshore wind. Turbines mounted on floating platforms similar to oil and gas semi-submersibles, moored to the seabed with chains. This technology opens up huge ocean areas where the water is too deep for fixed foundations, dramatically expanding the potential resource. Once the foundation is in place, construction of the turbine itself can begin. And this is where the specialist installation vessels come in. Wind turbine installation vessels, WTIVs, are among the most remarkable ships ever built. They are jack-up vessels, self-propelled barges fitted with enormous retractable legs. When a WTIV arrives on location, it lowers its legs to the seabed, then uses hydraulic jacks to lift its entire hull clear of the water. This creates a stable, wave-independent platform from which the crane can operate without the motion compensation challenges that plague floating vessels. The largest WTIVs have cranes capable of lifting over 3,000 tons to heights of 170 meters above sea level. The turbine itself arrives at the site in components, typically pre-assembled as much as possible in port to reduce time offshore. The tower sections, usually 2 or 3 cylindrical steel sections stacked on top of each other, are lifted one by one and bolted together. Each section can be 30 meters tall and weigh hundreds of tons. On top of the tower sits the nacelle, the heart of the turbine, containing the generator, gearbox, and drivetrain. Modern nacelles for the largest offshore turbines can weigh over 600 tons. Lifting one to the top of a 120-meter tower in open sea conditions and then mating it precisely onto the tower flange is a feat of crane operation that requires extraordinary skill and computerized load monitoring. Then come the blades. Each of the 3 blades on a modern offshore turbine can be 80 to 115 meters long, longer than an Airbus A380 is wide. They are made of fiberglass and carbon fiber composite, shaped with aerodynamic precision and hollow inside to save weight. Getting 3 of them attached to the nacelle hub, in the right order, at the right angle, in sea conditions that are never truly calm, is one of the most demanding lift operations in offshore construction. The world's largest offshore wind turbines today generate up to 15 megawatts each, enough to power thousands of homes from a single machine turning in the sea breeze. Wind farms like Hornsea 1 and 2 in the UK and Dogger Bank, which stretches across the central North Sea, contain hundreds of these machines, generating multiple gigawatts of electricity and connecting to shore through high-voltage submarine cables. Offshore wind has grown from a niche experiment into a cornerstone of global energy planning. Countries from the UK to Denmark, Germany to China, South Korea to the United States are investing hundreds of billions of dollars in offshore wind capacity. The installation industry that supports it has had to scale at a rate that has genuinely never been seen before in marine construction history. New, larger installation vessels are being built specifically for the next generation of turbines. Machines so tall that existing cranes simply cannot reach the hub height. The ocean is being industrialized in a new way, not for oil and gas this time, but for the clean energy that will power the decades ahead. And it all starts with a ship that lifts itself out of the water and a crane reaching into the sky.